integration. In this lecture, we are going to discuss how to change double integration into the polar form and example on it. Main motive of this video is student will know how to change the limit into polar form. In last lecture, we already discussed how to solve integration in polar form. We always integrate with respect to r first and then with respect to theta. Here r is varying from r1 to r2 and theta is varying from theta1 to theta2. This is the corresponding integration. Here function is already given into the polar form. But in this session, here we take the example, and in this example integral is given into Cartesian form, and we have to convert this integral into polar form and then we solve it. Here we observe that the integration limit is 0 to 2 and next is 0 to under root of 4 minus x square. Here it is in the form of x, so therefore this limit is for y, and this given next remaining is limit for x. So we observe that x equals to 0 to x equals to 2 is a limit for x, and we convert into polar form. So here we first draw the diagram corresponding this given limit. So here I draw the diagram. X equals to 0, it represents the straight line, that is y-axis, and y equals to 0 represent the straight line parallel to x-axis, it's nothing but x-axis. Also we have given x equals to 2, x equals to 2, again line passing through x equals to 2 and parallel to y-axis. This is the limit for x, and y upper limit is y equals to under root of 4 minus x square. If we squaring on both sides, to we get y square plus x square equals to 4. It means the circle with center 0 and radius is 2. If we shade this, all the curve is bounded in this shaded region, and we have to find the area, means we have to find this shaded region. So to solve this shaded region, we convert into the polar form, so that we take the PQ strip passing through origin. We already discussed that in last lecture. If we want to solve integral in polar form, we take the PQ strip passing through origin, and if we rotate this strip, our region is start from x-axis up to the y-axis. It means strip is start from theta equals to 0 to pi by 2. Here we get the limit for theta, that is 0 to pi by 2, and we observe that point P on origin, that is r equals to 0 up to the point Q on curve. So here curve is x square plus y square equals to 4. It means r equals to here 2. So therefore we also get the limit for r, that is r equals to 0 up to the r equals to here r equals to 2. And so therefore if we convert this limit into polar form, so therefore our limit is theta varies from 0 to pi by 2 and r varies from 0 to 2. That is here also show that r equals to 0 to 2, and x square plus y square. Here again x square plus y square is nothing equals to r square, that is equation of circle. So therefore it is r square r dr d theta. We know that dx dy is equals to in polar form r dr d theta. So therefore we get this type of equation. Now we have integrate this term, so we put r square equals to u. If we put r square equals to u and we integrate this u, r square equals to u, if we differentiate this u, so we get du equals to twice dr r dr. So therefore we get this type of integral in the form of u. We integrate this integral, we get 1 by 2 sine 4 d theta. Again lastly we integrate with respect to theta, so we get pi sine 4 divided by 4. This is our final answer. Similarly, I take the next example. If we again given the integral in the Cartesian coordinate 0 to 1 and next integral 0 to 4 y square divided by x square plus y square dx dy. Again we have to convert this integral into polar form and then solve it. We observe that here the second integral, that is 0 to 4, it means this limit is for x. So here x equals to, we have given 0 to y and y equals to 0 to 1. If we draw the figure, y equals to 0 is again represent x-axis and y equals to 1 means straight line parallel to x-axis. And here x equals to 0 is y-axis and x equals to y represent a line passing through origin. If we draw the figure, we get this type of figure, that is x equals to y straight line passing through origin, x equals to 0 that is y-axis, y equals to 0 is x-axis and y equals to 1 straight line parallel to x-axis passing through y equals to 1. And for this four given region, we shaded the region, that is here we shown by R. This is our region and we have to convert this limit into polar form. So again we take the strip, PQ strip passing through origin. So we observe that this PQ strip passing through origin, and we suppose we rotate this strip from starting our region is y equals to x. So here theta is equals to pi by 4 up to the y-axis, that is theta equals to pi by 2. Means we get the limit for theta is pi by 4 to pi by 2, and for r, here r equals to 0. Here r equals to start from this point to r equals to 0 up to this line. So here y equals to we have given 1. If we solve this, we get r equals to sec theta, and here we put this limit in the polar, we convert this limit into polar form. So we get theta varies from pi by 4 to pi by 2 and r varies from 0 to sec theta in bracket y squared. So here again y is converted into polar form, so y equals to r cos theta. So here square y square, so therefore r cos theta bracket square divided by r square. Again dx dy is nothing but r dr d theta in polar form. We integrate first with respect to r, always we integrate first with respect to r and then with respect to theta. We get the final answer, that is pi by 8. This is one example, we have to try it. Thank you. Hope you get the idea.